in reading this question, first of all, we notice it says solve, not prove. So that's important that we're actually solving an equation. They give us the domain from 0 to 2 pi. But initially, when we look at the question, we got cos 4x cos x plus sine 4x sine x equals 1. Technically, at this point, we cannot solve this question because we have sine and cosine. Now, we're getting some new formulas. Right? We got these 6 new formulas yesterday. We're going to get another 5 new formulas today. Our formula sheet is starting to get full. And we have to have these formulas mostly memorized because you need to be able to at least recognize that maybe a formula is possible. So, with the formulas for sine and cos, if you ever have 4 sines and coses added or subtracted, it might be one of those formulas. So I notice here I have cos plus sine sine. I'm like, is there a cos plus sine sine formula? Yes. There's cos alpha minus beta is cos alpha cos beta plus sine alpha sine beta. So this would be my alpha, this is my beta, this is my alpha, this is my beta. And I can use that formula to say alpha minus beta formula, and it's still equal to 1. So this question, we look at it to begin with. We see it has lots of sines and cosines, and we can't solve an equation unless it's only one trig function, or we can factor. But I recognize the formula, so I say, well, let's see what happens if I change it to the formula. And I get just cos of 3x equals 1. So I got a single trig function now. It seems like it should be solvable. Do you recognize what kind of question this is? We gave this a name. And the reason we gave certain questions names is because if you recognize it and know the name, that triggers your brain to remember how to do it. So if we can recognize what kind of question it is now, it should trigger your ideas. It is we call this a multi-revolution question. Now that's not officially what it's called, it's something I named it myself, but I find if you do those things, that helps you. You're like, oh, multi-revolution, and then your brain goes into, I remember how I did those. Or you're like, I have no idea how I do those. But a little review. How do we do multi-revolution questions? First, we rewrite the domain for 3x. And if 1x is between 0 and 2 pi, does it make sense that 3x's would be between 0 and 6 pi? And by rewriting the domain, 0 and 6 pi is 3 times around your circle. And that's why we would call them multi-revolution questions. Then we solve for 3x like normal. When is cos equal to 1? That's at 0 and 2 pi. But that's the first time around. Second time around would include 4 pi. Well, 2 pi and 4 pi on the second time around, and 4 pi and 6 pi on the third time around. And this is where I get frustrated sometimes with the textbooks. They really make you check your domain. Did you see that right here, that wasn't included? So right here, it's also not included, which means that 6 pi isn't part of our answer. So multi-revolution questions. First, we rewrote the domain for 3x, and then we solved for 3x over that domain. Now to solve for x, you would just have to take each of these answers and divide by 3. Yes?
What would 4 pi still be?
4 pi is okay because it's still in between 0 and 6 pi.
Yeah.
Right? And if we think about our unit circle, The only place that cos is equal to 1 on our unit circle is right here, right? Which is going to be 0. And in the first time around, technically maybe beginning the second time around, you hit 2 pi. And then again, you'll hit 4 pi. And then again, you would hit 6 pi. But in this question, 6 pi wasn't to be included. So we get our 3 answers this way. So sometimes the sum and difference identities in a solution question, if you combine them, then you get a multi-revolution question. And so you get some of this review of concepts that you've learned in previous units. Circle 15 and 17.